Alright, we've been looking at matrices and systems of equations recently, and so today we're going to take a step and focus on the matrices for a little while and really go into working with matrices. We're going to talk about matrix algebra, which is basically where we add and subtract and multiply matrices and do all the different operations with matrices. And then eventually we're going to even solve matrix equations. So equations that are made up of matrices. Okay, and so it's going to be kind of interesting. It's a little bit different than what we're used to. And so we've got to get back to the fundamentals first, get those down. So the first thing we're going to talk about is going to be just a quick review of a couple things you've already seen, but I'm going to review them anyway. The row operations. Okay, we talked about the elementary row operations when we did, we were solving systems of equations with a matrix, and we tried to reduce the matrix. So the main row operations, we'll call them elementary row operations. There were three of them that we talked about. Number one was that you could interchange rows. Number two was that you could multiply any row by a non-zero number or constant. Now when I wrote this out in the past, I said multiply or divide, but dividing really is multiplying by a fraction, the reciprocal. So we'll just count them both as multiplying. And I didn't use the word non-zero in the past, I don't think. But really, if you multiplied a row by 0, the whole thing would become 0, and then you've really lost that entire row. So you can't really use 0 anyway. Okay, so multiplying a row by a non-zero constant. And then number 3 is to add a multiple of one row to another. Okay, so these are your three elementary row operations. We've seen those before, we've worked with them. I'm not going to give any examples of them, but just as a quick reminder, because we're going to see a couple of these later on today. Also, just the idea of a square matrix. So these are just a couple of review topics, a couple of things I want to talk about. A square matrix basically by definition has same number of rows and columns. C-O-L-U-M, that is not what I'm looking for. N-S, there we go, close enough. Same number of rows and columns. Okay. Alright, so now we're going to look at some newer items, particularly a new matrix called the zero matrix. Okay, something called the zero matrix, and the zero matrix is kind of like you would guess, all entries are 0. That's it. Okay, so the zero matrix could be the matrix 0, 0, 0, 0, or 0, 0, 0, 0, 0, 0, 0, 0. So whatever size matrix you're looking for, maybe just a column of zeros, those are all a zero matrix. Okay, they all of the entries in the matrix are 0. Those are examples. Okay, we also have one type of matrix called the identity matrix. And an identity matrix is all ones on the main diagonal and zeros elsewhere. Okay, now when I say the main diagonal, that's the diagonal going down to the right. So an example, and this is one that we've seen before, 1, 0, 0, 1. The main diagonal is this one going down to the right. Okay, this is actually what we would call the identity sub 2 because it's a 2 by 2 matrix. Identity matrices must be square matrices. Okay, so you could have I sub 3 is a 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. And you can see the main diagonal here is all zeros. I'm sorry, is all ones, and there's zeros elsewhere, and so forth. Okay, so we call these the I sub n, where n is the size of the matrix. It's an n by n matrix. Okay, so 2 by 2, 3 by 3, and so forth. Okay. Okay, so then we're also going to talk about something called a row matrix. Okay, basically it has size 1 by m. In other words, it has one row. Okay, so it's a matrix. I'm missing a letter. Let me rewrite that. A matrix with one row. Okay. And then you'll guess probably what the next one is. It's a column matrix. And the column matrix has size n by 1. It's a matrix with one column. Okay, so these are just a few basic types of matrices that we're going to be talking about as we progress through this conversation.